In the cross product part 2, we're going to talk about the volume of a parallel piped and coplanar vectors. This here, A dot B cross C, is called the scalar triple product. The reason it's called the scalar triple product is because when you're done with the problem, you're going to get a scalar answer. The cross product gives you a vector, but you're going to get a vector times a vector, which we know gives you a scalar. And so if you think about order of operations say you got to do the cross product first because that's what's inside the parentheses. The nice thing about the scalar triple product is that you don't have to worry about I, J, and K when you're doing your order 3 determinant. Now you can just do the 3 components of A, the 3 components of B, and the 3 components of C. And since that's going to be 9 numbers, this is going to be really nice to do in our calculator rather than doing it by hand. What we're going to use the triple scalar or the scalar triple product for is to find the volume of something called a parallel piped. I'm going to start with this. This is something you know. This is just a general run-of-the-mill rectangular prism. A parallel piped is going to be a 3-dimensional parallelogram. I'm not sure that I did this picture justice, but I don't think I did too bad. So how do you find the volume of a cube? Well, the volume of a cube is length times width times height. But when we're talking about ordered pairs in 3 dimensions, there's other things we're going to need to know. We know how to find the area of the base of this parallel piped because the base is just a parallelogram. So it's going to be the cross product of these 2 vectors. So we'll call this vector B and vector C. Well, then to find the volume, you need a 3rd dimension. That 3rd dimension is going to be A. So it turns out I can find the volume of a parallel piped by doing the triple scalar product. Now the book writes it with this here, except that because the scalar triple product's already going to give you a scalar answer, you don't really need to find its magnitude because you're already getting that answer. If, however, you get an answer that's equal to 0 when you do A dot B cross C, then we say that the 3 vectors are coplanar. In this last example in this section, we are given vectors A, B, and C, and we want to determine if they're coplanar. They are coplanar if the volume, which is the scalar triple product, is equal to 0. So let's find out if this is equal to 0 or not. Now, you can do this by hand if you want, but I'm going to tell you the nicer way of determining this answer. On the graphing calculator, it will actually do determinants for you. You have to go put this into the matrix function in your calculator, though. So remember, if you go to second x negative 1, which is your matrix function, you arrow 2 to the right to edit. The dimensions of this particular matrix are 3 by 3. There are 3 rows and 3 columns. So change it to say 3 by 3 and then type in your numbers. Let's see, -1, 4 and 0, -9, 18. I'm plugging it into my calculator right now. Once you get the numbers plugged in, you quit. You go back to second x negative 1, And under the math function, I want you to use number 1 there that says determinant. So just hit enter, and then you have to tell the calculator what you want to take the determinant of. So you have to go back into matrix one last time, and then you're on names, and you're already on A, so you're going to just hit enter twice, and it'll tell you the answer is 0. This is only a good way to do a determinant if you are not dealing with a problem with I, J, and K. You cannot do the calculator method when you have variables in the problem. I shouldn't say variables, I should just say letters, because I, J, and K are unit vectors and not variables. But since this problem, the scalar triple product, is just 9 numbers, instead of doing it the long way, and you absolutely could have done 1 times -18 minus -36, and then done -4 times 36 minus 0, and then plus -7 times -18 minus 0, and you would have ended up with the exact same answer. But I like doing it in the calculator better. If you get any number other than 0, that answer is the volume of the parallelepiped. If you get 0, it means that these 3 vectors are coplanar. They lie on the same plane instead of in different planes, in which case you can't actually find the volume of it. And that is the end of section 9.5 on the cross product.